So the problem we're given is a block with a weight of 555 newtons, which is pulled up at a constant speed on a very smooth ramp by a constant force. The angle of the ramp with respect to the horizontal is theta equals 22.0 degrees, and the length of the ramp is L equals 13.5 meters. We are to calculate the work done by the force in pulling the block all the way to the top of the ramp. Neglect friction. So what we're given is our length of the ramp is 13.5 meters. So here we have 13.5 meters, and our angle that the ramp makes with the base is 22.0 degrees. So we have theta here equals 22 degrees. Now, we are already given the weight of the block, and they've already calculated the force of the block due to gravity, which is 555 newtons. So we have a vector heading straight into the Earth's surface, with magnitude 555 newtons. Now, in order to solve this problem, we need to solve for work, which is force times distance. So what we're looking for is the force of the block parallel to the ramp. Wrong tool. Force of the block parallel to the ramp times the distance of the ramp, which the distance we already know. So really all we have to do is solve for this vector here in the direction of our ramp. So in order to do this, we have to break our vector heading straight down into the Earth's surface, the 555 Newton vector, into its components. So we'll get a vector perpendicular to the ramp surface, and a vector parallel to the ramp surface. And this vector here will have the same direction and magnitude as this vector up here. Alright, so that's really what we're solving for when we solve for this vector here. First thing we need to do is work out a little trigonometry to figure out these angles, or this angle here specifically, so we can use some of the trig functions to solve for these two vectors, our components of our 555 Newton vector. Now we know that the vector heading from the block straight into the Earth's surface will be perpendicular to the Earth's surface, or we could say perpendicular to the bottom of the ramp here. So that means that this angle here is a 90-degree angle, and that's the little symbol there for 90 degrees. I'll go ahead and write it. 90 degrees. Now we just need to solve for this angle here, and by properties of triangles, we know that all the interior angles of a triangle will add up to 180 degrees. So we solve for that angle by taking 180 degrees minus 22 degrees minus 90 degrees. And this will equal 68 degrees. So we've solved for this angle up here, which is 68 degrees. Now we need to solve for this angle here. The vector heading from the block straight into the surface of the ramp is perpendicular to the ramp surface. So we know that this vector and the ramp make a 90-degree angle. So to solve for this angle here, we know the sum of these two angles equal 90 degrees. So to solve for this angle here will be 90 minus 68 degrees. 90 minus 68 degrees. So we take 90 degrees minus 68 degrees, and we get 22 degrees. So this angle here is 22 degrees. Now we can just use trigonometric functions to solve for our vector perpendicular and our vector parallel to the ramp surface. Really, we don't even need to solve for this perpendicular vector. We can just take the angle that we know and solve for the vector parallel. And this is going to be a sine function. And we know sine theta equals opposite over hypotenuse. So our hypotenuse in this case is 555 newtons. So 555 newtons times sine 22 will equal the magnitude of our vector parallel to the ramp surface. So we'll go ahead and solve for that. We have force parallel, and this is just going to be that vector. I'll label it up here so you can see what force parallel, what I mean by that. Force parallel is what I'm labeling this vector right here, is equal to 555 newtons times sine 22, sine of 22 degrees. And what this gives us is 207.9 newtons. So we solve for the magnitude of our vector, our force parallel vector. Now all we need to do is use our formula for work, force times distance, and solve for the amount of work needed to move the block from the base of the triangle all the way to the top of the triangle, or the top base of the ramp all the way to the top of the ramp. So we have work equals force times distance equals 207.9 newtons times 13.5 meters, which will give us 2,806.65 joules. Newton meters is equivalent to joules. And that is the answer. That is the amount of work needed to move the block from the base of the ramp all the way to the top of the ramp.